Okay, when dividing with radicals, we need to make sure that we do not have a radical in our denominator or our bottom number. So if we do, like in this case right here, we have a radical 8 in our denominator, we want to do what's called rationalize the denominator, and we do that by multiplying the top and the bottom by the radical that's in the bottom. So we can look at the top, we can multiply through 7 times, radical 7 times radical 8 can combine, so I can say that those are 56x and they stay in the radical. And then on bottom, remember my, my trick, I can show you if I have radical 8 times radical 8, it's going to give me radical 64. And then if I break that down, it's going to have a pair of 8s, which I started with, and it's going to come out of the house and turn into 8. So if you can just remember the trick that any radical multiplied by itself is just that same number out of the radical. So we would have 8 here. Okay, we can break down the 56 even further. Let's just use, I don't know, 7 and 8. 7 is a prime number, so that's going to definitely stay inside of the house. And I know that 8 can come out as 4 and 2. Those are going to come out with a pair of 2s. So I'm going to have a 2 that come out of the house. And I have this also, this 2 right here that has to stay inside the house, but it has to be multiplied with the other 7 because they both stay inside the house. So 7 times 2 is going to give me 14, and that's going to be over 8. And then look at these two numbers that are outside of the house. I can continue to reduce those even further. So I can say 2 goes into 2 times once, so I won't have that number. If you want to write it, you can. You probably won't see it. It'll just look like that. And then 2 goes into 8 4 times. So radical 4, oh, I forgot my x. My x didn't have a pair, so it has to stay inside of the house, and it is part of my answer. So that's what that answer would look like. All right, looking at number 2, I cannot have a radical in my denominator, so I'm going to multiply the top and the bottom by the radical. So radical 6 times radical 6 just means the 6 comes out of the radical sign. And then that's going to turn into radical 2 times 6 was going to give me radical 12. All right, so I want to see if 12 can break down any further. And I know that a 4 and a 3 is going to pull out a pair of 2s. So this is going to reduce to 2 radical 3. Those pair up, come outside of the house. That guy has to stay inside the house. All over 6. All right, now we're going to look at our numbers out in the front, outside of the radicals, and those can reduce. So I'm just going to cut those in half. So 2 divided by 2 is going to give me 1, but you won't see that. And then 6 divided by 2 is going to give me 3. So radical 3 over 3 is your answer on that one. Okay, sometimes you'll see something over like a giant size radical sign like this one. So if you want to rewrite that, it's really the same as just radical 5 over radical 6. And then we would continue to rationalize the denominator by multiplying both sides by the denominator of radical 6. So it comes out of the radical sign as a 6, and I have radical 30 on top after I multiplied. So I'm going to break the 30 down. I can say, what do I like in 30? 6 and 5. 5's prime. 3 and a 2 are going to come out. And those don't have pairs, so those have to stay inside of the house as well. So it looks like radical 30 is the most reduced I can make that. So this would be my answer, but I'd always want to check first to see if there are anything that can come out of the house. All right, if you want to rewrite this one so you can clearly see that we're looking at a radical 1 over radical 6, you can do that. And we're going to multiply the top and the bottom by the bottom radical to get rid of it. So on top, I'm doing 1 times 6, which is radical 6. And on bottom, radical 6 times radical 6 just gives me 6. And I know that 6 will not break down because 3 and 2 are the only things, and they're not going to pair up, so nothing comes out of the house. So this is my answer. All right, so we can make it look like a pencil. Hang on. Okay. We have radical 12 over radical b squared. So we are going to multiply the top and the bottom by radical b squared. that's a 6, b squared. Okay. So on the bottom, it just comes out of the radical as b squared, but on top, I have radical 12b squared. So I'm going to want to break down the 12 so I can pull out a 4 and a 3, and I know the 4 is a perfect square, so it's going to pull out a pair of 2s. So a 2 is going to come on the outside, and notice I left a space here because I noticed that I also have b squares, so I know that those are going to pair up. The two b's are going to pair up and come out as 1. And then this 3 is going to be left inside the house, and that's all going to be over b squared. Okay, so now I can continue to reduce, and I might have to remember exponent rules on this one. So remember, when we are dividing exponents, we're really subtracting them. So we're going to subtract a b out, so that's going to turn into 2 radical 3 over b. Alright, so if I want to rewrite to c, I'm looking at radical cube over radical 12, and radical 12 is my issue. I need to get rid of it by multiplying the top and the bottom by the radical. So on top, I am left with a radical 12 cube, and on bottom, it comes out of the radical as 12. So I would want to try to break up 12, and I know I can break it up into a 4 and a 3, and a pair of 2's come out of the house. So that's going to come out of the house as 2, and then this 3 gets left over in the house, and also this q doesn't have anyone to pair up with, so it's going to stay inside the house too. And we're going to rewrite the 12, and now it looks like I have an opportunity to reduce the fraction of 2/12. That's going to reduce to 1/6. So on top, I'm going to have 3q, and then 2 goes into 12 6 times, so I'd have a 6 on the bottom.